All right. So, like it says at the top, this is a recap assignment. Things bombed last week. I'm aware things bombed last week. It did not go super well for everybody. Some of us did awesome, and that's great for you. If it is, this is going to be a really easy section if you've already got it. Okay, first things first, make sure your name's at the top and put hour 2, 5, or 7, depending on what hour you were in. And then the front side we're going to do together. It says classwork. We're going to solve these together. The back side says independent. You're going to solve those on your own. Okay? Because even if you are in person and you can work with somebody else, I really want you to stay in your seat right now so we don't end up having to go remote again. So systems of equations means you have two equations together. Okay? And the solution is either the point where they cross if you're looking at a graph, or if you're looking at the equations, it's the point that makes both of them true. So you kind of have to solve the equations put into each other, or graph both of them and look at where they cross. And our three methods for solving them are graphing, substitution, and elimination. We're going to talk about graphing and substitution today. We're going to save elimination for 4.4. Okay. And basically, these two ways are, if you're graphing it, you just simply graph both lines using any method we learned in Unit 3, and then write the point where they cross, x comma y. If you're using substitution, you look for the equation that has either x equals or y equals by itself. You substitute that into the other equation and solve it. This is going to involve distributing and combining like terms and all that good stuff, which is what we did back in Unit 1. And then you plug your answer back into whatever you were using right here in step 1. So you kind of come back to step 1 full circle at the very end. Okay? Substitution should be the more difficult one because, again, we've been graphing lines. We did an entire unit over graphing lines. Now we're just using that to figure out where they cross. And now that you don't have to do it on the computer, it should be 1,000 times easier, which is another reason why I wanted to do it again today. Not because I don't think people understood it, but because I want you to at least get the experience of doing it by hand because it's so much easier. So, for example, on the left, this line is going to start at 1 and go up 1 over 3. Use the slope as 1/3. And I'm going to go down 1 left 3 also. If you make your points go all the way across the grid, that is going to be your best friend in this section because then you're guaranteed that it will cross at one of those points and not somewhere else weird. And then connect them with a straight line. The other line is going to start at -4 on the y-axis and go up 2. And there's no over part on this one. There's no fraction. So what a lot of people do is they put a fraction over 1. So up 2 over 1. And if you keep going up 2 over 1, you will eventually get a point that's already on there, right there. And that's your answer, is this point where they both crossed, which is 3, 2. And that's solving it by graphing. It was really tricky when we were on the computer, so people hated it, which is really sad because it's actually one of the easiest sections that we ever covered, at least for this type of thing. Seems really hard solving two equations together, but when you can just graph them, it's a whole lot easier. And then I'm going to keep going with this one. It's still in y equals mx plus b form. So 5 is the y-intercept. You start at 5. The slope is -1/2, meaning you're going to go down 1, right 2, like this. And it's going to be harder to check my graph than it is just going to be count it down 1, right 2. And then the other one is kind of tricky because it's not y equals. got x on the wrong side. All you have to do is cover up your y's and say, okay, 3x equals 6. Divide by 3, x equals 2. And then cover up the x's. Negative 2y equals 6. Divide by negative 2, y equals negative 3. So you put a point where x equals 2 and a point where y equals negative 3 and draw a straight line goes through them. This is straight lines again. And my answer is right here. That's over 4 up 3. The x value goes first, like that. Okay. I want this section to be like your best friend because graphing lines is not that difficult. You should be learning about it for like the second or third time. And it shouldn't be too big, other than the fact that you may have never put two on the same line before, the same grade. Okay, then we're going to work on substitution. This is the one where it gets a little bit more difficult, but I think writing it out is going to be more natural than typing it up. I think some of us just don't think through it the same way. What you're going to do is look for a piece like this that has just an x equals or a y equals on the other side. This one happens to be an x equals. So guess what you're going to do? Replace that with x right here. And then you're going to rewrite that bottom equation, but instead of x, you're going to put 3y minus 2 in parentheses. And the only thing that changes about the equation is you don't have an x. The whole point is that you took out x and replaced it with y, because you can't solve an equation with two letters. But now we have the same letter. And the solving part is going to take like 2 steps. Multiply this parentheses and then just solve it like normal. So 4 times 3 is 12. And 4 times negative 2 is negative 8. And then write the minus 5y equals 6 at the end. And from here, like this is where we're a little bit more comfortable solving. Put your x's together, or sorry, y's. 12 minus 5 is 7. Add the 8 to the other side. And divide by 7. And that's half of your answer. You'll notice we haven't found out what x equals yet. This is the easy part, but you have to remember what to do for it. It says plug the answer back into the equation from step 1. So the one that I circled up here, x equals 3, and instead of y, I'm going to put 2. So I'm using that thing that I circled up there again. And 3 times 2 is 6. 6 minus 2 is 4. Okay, now I'm showing every little step to you guys. You do not necessarily have to do the same thing for me on your work. I'm just doing it because I need you guys to see it. And then we're going to do the same type of thing on the next one. Except for when I look at it, this is the part that has y equals. It's on the bottom now. There's no difference, it just happened to be on the bottom instead of the top. And you're going to plug that in for y, because it's what y equals. So I'm going to rewrite this entire equation, but instead of y, I'm going to put negative 3x plus 2. And I know it's weird, But there's got to be a way of solving an equation where you replace one variable with the other one. And that's the easiest way to do it. And then I'm going to multiply by 3. Stop me if you're not sure why I write any of this. 3 times negative 3x is negative 9x. 3 times 2 is 6. Depending on how comfortable you are solving equations, this part is going to be either easy or difficult. What does that go next? 5 minus 4, or 5 minus 9, negative 4. Subtract the 6. Some of us have stopped writing the minus 6 on each side. That's okay with me if that's you. And divide by 4. Negative 4, sorry. X equals negative 1. 4 divided by negative 4 is negative 1. They do not just cancel out. Then plug that answer back in to this part that you had boxed up here. So drawing that box is actually really helpful. It's not just something I randomly do. Because that x is going to become negative 1. And that makes 3 plus 2, which is 5. So your answer is negative 1 comma 5. Make sure you always put your x value first. And then I'm going to do 2 word problems to end off notes for today. They are both extremely easy. However, I am asking you to interpret the problem a little bit. So that's the reason why I'm doing 2 of them, is because I do want to show you how to interpret this. So the first problem says, Frugal Fred has $24 on Monday and spends $4 per day on lunch. What he starts with is the y-intercept. So you'll notice this is only a corner of the graph. It doesn't include any negatives because it doesn't really make sense for time to go negative. Technically, Fred could go negative in money if he has a credit card. Well, let's say he doesn't have a credit card, then he can't spend money he doesn't have. Okay? He's going to start up here at 24. So this is going to be the amount of money he has. And this is going to be the number of days that he goes and spends $4 on lunch. This is the only part of graphing that's a little tiny bit tricky, but when you think about it, it's not so bad. He spends $4, which means we're going to go down $4 in over one day. So the next day he should have $20 left. And you'll notice that that's only going down one square because of the scale. So you have to make sure you read these numbers over here on the left and actually pay attention to what they are. So I'm not actually going down 4 squares over 1. I'm going down 1 square over 1 because each square is worth 4. And that's his slope, so we're just going to keep following it. Like that. You can kind of see that he's going to run out of money on day 6. And then we're going to do the same thing for Spendy Spencer. I'm going to label this line with an F for Fred so that we remember who is who. And Spendy Spencer starts with $40, but he's not very frugal. He doesn't look at his money and how much he's spending. He spends $8 on lunch. So I need to go from 40 down to 32, which is 2 squares. And I'm going to keep doing that the whole way down. So even though Spencer started out with $40 because he's spending more, he's losing money a lot faster. And what we want for our answer is the solution where they cross, right here at 4, 8. And what you have to do is interpret what this means. It's not that hard because the 4 is on the days axis, the 20 or the 8 is on the money axis. So after 4 days, they both have $8. So you sort of need to tell me the 4 means days, the 8 means dollars, and this is where they both have that much. So there's kind of 3 pieces to it. What does the X mean? What does the Y mean? And then tell me in some words that this is where they're the same. Some people on this one also would say if Monday is the day that they're starting, then it would go Tuesday, Wednesday, Thursday, Friday. So technically 4 days later would be Friday. You don't have to go that far, that's fine. I'm just showing you that you could do that if you wanted to. And then it says who has more money at the end of the week. There are 5 days in a week, or at least in a school week. So that would be day 5. And if we go over to day 5, Spencer's out of money, but Fred still has $4 left. So Fred. Okay. And then we're going to do the same type of thing with the next one. Karen's cabs charges 0.25, we're going to talk about that in a second, per mile, and a pickup fee of $2. What that means is you have to go spend $2 just for Karen to hire Karen's cab. Okay. And again, that's going to be your money over there on the left. And then it's based on the number of miles. So it says per mile, whereas up above it was per day. So the part that says per or each after it, A, that's your slope, and B, that tells you what the x-axis is going to be. So now I need a way of going up 0.25. That's just 1/4. 0.25 is the decimal for 1/4. So we're going to go up 1/4. Like that. And I'm going to write a K for Karen at the end of this. Tyler's Taxis starts with no pickup fee. That means you don't have to spend any money. You can start at 0. And he charges 50 cents. 0.5 is the same thing as a half. It's half of $1, 50 cents. So we're going to go up 1/2. And sometimes I'll tell you guys what those fractions are, but honestly, it ends up confusing people more when I do that, usually. And that's T for Tyler's Taxis. And these lines cross right here at 8, 4. 8 is on the miles axis. So for 8 miles, both cost $4. Which is pretty cheap, right? Actually, really cheap. And then it says who charges more for a 5-mile car ride. Go to 5 on the miles. We're going to look up. The one that's higher is charging more. The one that's lower is charging less. So green is Karen on mine. So Karen is charging more for a 5-mile car ride. This one throws some people off because over here on theirs, you can actually see the points and compare them. Here it's somewhere in between the numbers. You don't really care what the exact number is, just that Karen's line is higher than Tyler's